Hi, my name is Michelle Broussard, and today I will be taking you through the linear regression feature on the TI-84 graphing calculator. So this is the problem that I use with my students. It asks to use the linear regression feature on a graphing calculator to find an equation of the line of best fit for the data. Find and interpret the correlation coefficient. So the first thing that we need to do before we start working in our graphing calculator is to write down the set of data points given to us. So we're going to look at this graph and we're going to make a table of our data points. So we have 1, 4, 2, 5, 3, 3, 3, 4, 4, 1, 4, 2, and 5, 1. So we're going to use this later in our graphing calculator when finding our line of best fit. So now we're going to go over to the graphing calculator, and there's a few things that we need to do to set up the graphing calculator to use the linear regression feature and to be able to interpret the correlation coefficient. So the first thing we're going to do is we're going to turn on our diagnostics. And to do that, we're going to hit second, 0, and then we can hit alpha, D. We can hit that twice and it brings us down to our D's. Then we're going to arrow down to find our diagnostics. And we're going to select a diagnostic on. And then we have to hit enter again, and now our diagnostics are on. The second thing that we need to do is we need to make sure our stat plot is on, so it's plotting our scatter plot and our data points. So to do that, we're going to push second, y equals, and we're going to select number 1, and we're going to turn on our stat plot. And the type selected is the scatter plot type for us to graph our data points. The next thing we need to do is put in our data points. To do that, we're going to hit Stat, Edit, and now we're going to put in our data points that we listed before. And then make sure the points correspond to the correct X and Y values. Okay, now we've put in our data points, we can hit graph, and we notice that they have graphed onto our graphing feature. Now what we can do is we can always check our window and change our window. Since this is in the first quadrant, we can set up our window to be different, and if we have different data points that are larger numbers, we have to put in a larger window for that. So I'm going to go from 0 to 10, and then 0 to 10 on my X and Y, and let's see what that looks like. And now we get a better view of our data points, and that looks like our graph that was originally given to us. Now what we need to do is the linear regression feature. This is the feature that's going to give us our equation of our line of best fit. So to do that, we're going to hit Stat, we're going to arrow over to Calc, and we're going to select number 4, our linear regression feature. And depending on which model or operating system you have of your calculator, you may have to hit enter once or several times to get to calculate. And so now it gives us some information. It gives us our equation of our line, y equals ax plus b. It tells us that a is -1, b is 6, and our correlation coefficient, which is our r value, is a -0.85. And we're going to use these pieces of information to draw a line of best fit. So our equation is y equals -x plus 6, and our correlation coefficient is about a -0.85. So now I want to look at my graph and see if our line of best fit does actually fit well. So to plot this line of best fit, I'm going to hit y equals. Since our data points were already blue, I'm going to select the pink color, which is really nice if you have the color graphing calculator. And I'm going to put in my equation, negative x plus 6, and then I'm going to graph that. And that looks like a really good line of best fit. There's an equal amount of points above and below the line, and there's a few points on the line. And we can use this to predict data and interpolate information given to us. So now what we're going to do is we're going to write down our equation and our correlation coefficient. So our line of best fit our equation was y equals a negative x plus 6. Our correlation coefficient was about a negative 0.85. And the students have already been taught about correlation, and so they know that if it's a negative 0.85, that is a strong negative correlation. So this model is a good model for the data set that was given to us.